Okay, so this is lesson 27, solving quadratic equations by graphing. So we're going to do 3 examples here, and you'll see right away there's 3 very distinct examples. One is going to have 2 solutions, one is going to have 1, and one is going to have no solutions. And we already talked about this with the discriminant when we were talking about the quadratic equation. So the main thing is if you can change the graph around from a standard to vertex or vertex to standard or even factored, you can graph many of these equations. If you ever get stuck, you can always do a table of values. So let's look at this first one here. So we have x squared plus x minus 2. So right away we know that negative 2 is the y-intercept. You can see that that's the y-intercept right here, right? Then you can go back and look through these and you go, okay, I can take this equation over here and I can factor it into 2 pieces, x plus 2, x minus 2 right here, right? And we can set it equal to 0. So we know, oh, look, our x-intercepts are negative 2 and 1. Okay, so if you look at the graph, you can see that right away. So 1, negative 2. There is our y-intercept there. Let's graph this. Sorry, let's change this to vertex form just to see what the vertex is. So practice. That's all it is. So what we do is we got this thing. First thing we do is push the negative 2 over to the right-hand side. Then we set up our brackets. Now, the number that we're going to take to deal with here is whatever is in front of the x, and there's a 1 in front of it. So it's 1 divided by 2, yeah, and then we're going to square it, and a half squared is a quarter. So what we're going to do is we're going to add a quarter inside, and to keep it in balance, we add a quarter outside. Okay, and then we set it into 2 binomials. It's x plus a half and x plus a half. Where did we get that from? Well, you can see right over here. That's the number we're dealing with, so that's the one that goes in there. And then negative 2 minus a quarter is negative 2 and a quarter. And you could leave it in mixed, or you can change it to improper if you want. It doesn't matter. Okay, so x plus a half squared, same thing. So there's our perfect square because they're the same. And then minus 2 and a quarter. So what's the vertex? Well, what do we plug in here to make it 0? Right? We plug in negative a half. And what number is out here? Negative 2 and a quarter. So there's our vertex there. So negative a half, negative 2 and a quarter. And we can sketch it out. But what they're actually asking you, it says solve. When they say solve, they're looking for the x-intercept. So x is negative 2 and x is positive 1. And if you wanted to, you could set it up with a table of values, x and y, pick some values of it, plug them in, get your y values, and move on. Okay, example number 2, next page. This one is to graphically determine the roots of the equation. All right, so what we got here, you can see right away, it's in this form. Hey, what's the y-intercept? Right away, the y-intercept is negative 16. You can see that we put that down here. The y-intercept is negative 16. Okay. Before we get to completing the square, let's look at this one here. We can take the trinomial over on the side. We take out a negative 1. We have a trinomial, and then we can factor that into 2 binomials, x minus 4 and x minus 4. Oh, it's interesting. They're the same. So we only have one answer. Our x-intercept is 4, 0, right? What number do we plug in there to make it 0? So 4, 0, right? So there's one of the things. The other would be the y-intercept way down there. We know, hey, it's a negative 1. We know it opens down. But let's find the vertex. Like, you could unsure that that's actually the vertex. So let's complete the square. So go back up the top here. We set up the trinomial. Push the negative 16 to the outside. But now, what did we say? X squared has to be by itself, and it has to be positive. So do we have to pull a negative out of this? Of course we do. We pull out a negative 1. All right, so that makes that x squared minus 8x, and then we got to figure out what to do. So now, the number we're going to use is the negative 8. So negative 8 divided by 2, yeah, that's what we're going to do. Negative 4, and then we're going to square it. So we end up with positive 16. So we would normally add 16 in the center, in the inside here, and normally subtract 16. But there's that negative 1 out there. It's going to affect this. So what we do is we do our negative 16 minus our negative 1 right there. Little like cheat notes up the top, and then we end up with a positive 16. Okay. Now we're going to break it into 2 binomials. So x minus 4 and x minus 4. Where did we get that from? Oh, look, there it is right there at the top, the x minus 4. And then negative 16 plus 16, well, that's 0. So they cancel out. So if you see, we're left with negative out the front there because the parabola opens down, and it's x minus 4 squared. And we can look at that. What do we plug in there to make that 0? 4. So our vertex is 4, 0. Look at the graph. Oh, yeah, 4, 0. So that actually happens to be the x-intercept and the vertex. Sorry, the graph should be going through that point. It just didn't show up very well on here. Okay, so that's the second example. The first one was 2 going through the x-axis twice. This one is touching the x-axis. You want to take a guess on the next one? Yep, it's going to be no x-intercepts. But let's take a look. So solve this graphically. Look at this. This is interesting. You got to be careful. Sometimes they're in the wrong order. That needs to be equal to 0. So you need to rearrange it. So 2x squared minus 4x, bring the negative 3 over the equal sign. It's going to be positive 3. Okay, so now we have a lovely trinomial. First thing we do, push the 3 to the side. Okay, So then we set up our brackets, and we're going to fill in the spot here. We're going to fill in the spot here. To do that, x squared has to be by itself. Oh, it's not. There's a 2 in front of it. So we need to factor a 2 out of these two pieces. So we factor our 2 out. So 2x squared divided by 2 is x squared. Negative 4x divided by 2 is negative 2x. Now, you got to be careful again. Which is the number you're going to take and do the work to? Well, it's this one, the one where you factored out. So we're going to take a negative 2 divided by 2, and then we're going to take that, we get negative 1, and then we're going to square the whole thing. Remember, it's perfect squares. So we end up with positive 1. So now what we're going to look at is you normally would add 1 here, and to keep it in balance, you would subtract 1 on the outside. But, see, subtract 1. Does it get, do we have to deal with this 2? Yes, it does. And it was safe in the brackets there. Now it's coming out, and it gets attacked by the 2 here. So negative 1 times 2 is negative 2. So 2, x minus 1, x minus 1. Hey, where'd those x minus 1s come from? Oh, look, they come from up here. Yeah, there it is, the x minus 1. And then positive 3 minus 2 is our positive 1. So if you look at this, we have y equals 2, x minus 1 squared plus 1. So what's the vertex? 1, comma 1. Look at the y-intercept. What's the y-intercept? The y-intercept way back up here is positive 3. So let's graph this. Oh, positive 3, 1. Well, this opens up. So since it opens up, does it ever cross the x-axis? No. So there is no roots, no zeros, no x-intercept, no solution. Multiple ways of saying it. But basically, since it opens up and does not cross the x-axis, there is no solution. All right, so that was lesson 27.